slightly accurately with train accuracy. So it may not be helpful. I hope also at the time we received the 85%, still our end users are still our stakeholders may not be acceptable. 79 must they won't acceptable. So this is also somewhat overfitting kind of the thing. So what do you have to do? What you have to do? So many things we are going to be failed together, right? So at that time, what exactly you have to learn? So same thing will repeat in the classical ML also. We had learned so many things to do some of the hacks also, hyperparameter tuning and k-fold cross validation technique. Iteratively, we are going to be do. And similarly, we can also go with boosting or bagging, and we can also go with pre-trained mechanisms. So we have other different acts also, but these are some standard top four top five kind of the thing stuff. So first thing, hyperparameter tuning. We have so many hyperparameter tuning in this CNN, I can say. So increase the number of the model layers. This is also one of the hack, and increase the number of the filters in each convolutions, like numbers 32, 62, 128. Okay, so then training of the longer sequence for the more epochs. So we just know around, I think, five only. I think, yeah, five epochs are five. To increase the more number of it takes some time, but it will be get the good results at the end. So these are some of the hacks, I can say. We have to be stick with not only for the five epochs or not only for the 32 input shape for the convolutional layer, along with the model shapes in the hidden layers. How many hidden layers is going to be help us to understand to that predicting of the or classifying the pizzas. At the time, you can slightly going to be increasing, and also use transfer learning. That is a basic approach, I can say. Whenever you require, you can use a pre-trained model already train someone else with 100 billion images. 100 billion images. So that's how it's going to be probably get a lot of the data corresponding to the pre-trained mechanisms, but it will take some time. Corresponding to, you can also enable your enable your gpu and try to run that cells. So leverage that according to whatever the inputs you required, because still you are not satisfied with your results. So accuracies may not be satisfied, loss also may not be satisfied. At that time, you have done all the things, you have to perform these things also much better. So let's do that maybe. So in the AI model, what we are going to do, taking the same hidden layers what we had, taking the same hidden what we had, same input shape in all the images, and corresponding to that, the small modification in this, we are just taking as a VGG16. So instead of taking as all the model at a time, we are taking as VGG16 for that model, so that it will be flattened with respect to whatever the existing model we had. So go and see the model 7. Yeah, so this is a simple model to try to understand, but in this case we haven't take the VGG16 corresponding to whatever the pre-trained model we had. We can also do hyperparameter tuning in the next model. Yeah, so we can also do the hyperparameter tuning in the next model, but what will happen, slightly increasing some of the number of the epochs, and also you will get slightly improving with VGG16. So VGG16 we maybe see tomorrow. This is the pre-trained mechanism, which is also very popular and elegant mechanisms, I would say. So yeah, before that, we can also go with something called as a dropout mechanism. So this is also one of the hack, I can say. So what will happen, the dropout mechanisms, you are training with more number of the epochs, that is fine, but it takes maybe 1 or 2 days to run the your notebook, maybe 1 or 2 days. So epoch 100 for your large data set. It will take 1 or 2 days. So at that time, what you have to do, the simple hack is dropouts. So what will happen if you have a complexity neural network? At that time, you taken as a dropout of 0.2 or 0.5. By default, is going to be 0.5. So what will happen if you mention as a dropout? If you go and check out the documentation, you can see here the probability of each and every neuron it's going to be dropped off. So at the time you dropped off some of the neurons, you can see somehow it may be learned few of the things, it may not be learned few of the things. So in this case, what will happen, few of them are unuseful information holding this weight, few of them are useful information holding this weight. So whoever having unuseful information with corresponding to the node, it will be drop off. So this will be drop off, this will be drop off, like that. So it will also get some probability to get that information to understand with the corresponding to the each and every node. So if the probability of the information is less when compared to the this node, it will be drop off, it will be drop off, it will be drop off, like that. So once you drop off those things, you can compare with these two nodes. It having around 15, it having around 5 plus 5 10. So it will be slightly faster when compared to this. So at the time you drop some of the features or some of the nodes, it will be somehow going to be increase your efficiency to compute. So this is a much more easier way to understand the dropouts. So you can also specify to mention drop